Here we are going to discuss about a case study on autonomous navigation concept. So we know as autonomous navigation, the first thing comes to our mind is a self-driving car. So not only a self-driving car, we have more than that. So autonomous navigation is nothing but a robot or a device moving from one place to another. So it may be any of the system moving from one place to another, we can call it as autonomous navigation. For this autonomous navigation, we have to focus on few concepts like perception, localization, path planning, control systems, and mobile robotics, etc. So not only in self-driving cars, we have drones, delivery robots moving from one place to another, and in industrial automation also we have few robots like warehouse automation. We have robots carrying the loads from one place to another. So not only self-driving car, so more than that we focus on this autonomous navigation in both industrial and in cosmetics fields also. We have self-autonomous like in warehouse, etc. And here in pick and place, in the past we only focus on picking an object and placing it in one place. So now the pick and place robots are also made for a navigation purpose. So we have a warehouse where it will be in 20 to 30 feet from one place to another. The robot will not able to move its arm from first place to last rack. So in that cases, they made that robot to move from first rack to 30th rack also. So from first rack to 30th rack, the robot moves, and that particular concept is also called as autonomous navigation, where there will be no human interaction. It takes a decision on its own. So that is autonomous stands for. So let us discuss by taking some of example, some of industrial example, or whatever the most optimal we can take it, and we can discuss this concept. So can you go with some any of application or example?
Yes, ma'am. We'll take a real life example. The Waymo, there is a company which is an autonomous driving cars. What the problem statement here is, in people, while people are driving because of their fatigue or their like not focusing on the road, accidents may occur, and there are many fuel inefficiencies because they don't actually know the proper route. So to solve this problem, we need an objective. The objective is to create an autonomous car which could run properly, should stop properly at traffic signals, and respect all the pedestrians walking, and it should follow the lane properly. For this is our objective to create. The main components, as you said, is perception, localization, mapping, and yes ma'am, these are etc. First, perception. What perception is a sensor. It will detect like where to go, which is the proper route. It uses camera and all those modules it uses, ma'am. For localization, what it does is it uses GPS to find where properly the car is or where the vehicle is, and it should like analyze all the environmental conditions. For this, localization is used. And the next is it's used as mapping, because it needs to follow the proper route, because in fewer roads we find the white lines of the road being so wider. In few routes it will be so small, so that the vehicle should properly follow those lines. And the next is control system. What the control system, it's starting, accelerating, braking, everything comes under control system. And another concept also there, what it says is it needs to understand how the pedestrians walk. It should not collide with anyone. It should properly follow all the traffic signals. These are the core components of it.
Good. So can you go with another topics apart from the components of this Waymo?
Now we can see the challenges in the automation navigation. I am having a 5 main challenges: dynamic environment, sensor limitation, edge cases, real-time processing, safety and reliability. First, the dynamic environment, moving objects like vehicles and pedestrians, and predict difficult and require real-time objects. And sensor limitation, sensor may fall in fog and low light, reducing accuracy for problems. And edge cases, rare and unexpected situations like road fall and accidents, and sudden AI system may fall. And real real-time processing requires very fast computations. It may affect the instant delaying, and without decisions it may occur. And safety and reliability. System must be highly accurate with zero error to avoid accidents, ma'am.
Good. So, can anyone tell me any other features of this? Features of
Yes, ma'am. Working process of the autonomous navigation, environment sensing, sensor capture 360-degree surroundings, and data processing. It analyze the AR models of the sensor data, and decision making. It would be making the decision how the vehicle need to stop and go everywhere, and the mapping where the vehicle are standing. It identifies on the map, and continuous feedback loop adjust in real time where the vehicle is standing.
So, any other points to add with this question?
By the solution and technology, we uses deep learning for object detections and sensor fusion for improved accuracy, reinforcement learning for decision making. An example like Tesla car uses the vision navigation system for navigating the system.
Good. So nowadays we are working with the machine learning concepts for this navigation purpose. So in this navigation, mostly we are using the deep learning concepts like you said, going with the deep learning. Another example is reinforcement learning. Like you said, Tesla car. In Tesla, they are implementing the reinforcement learning, with where the car goes on studying on self-learning. So there is no algorithm or no data set, clear data set is given. Then car goes on the environment, it learns with the environment, it learns the obstacles, and from the obstacle it takes the feedback, and another data set will be created by on its own. So here the most autonomous navigation, we are going with the machine learning. In that machine learning mostly we are focusing on reinforcement. So I think now you will be having great clarity on this autonomous. So please don't conclude that autonomous navigation is only for the self-driving cars. We have more than applications in our mechatronics fields. Especially as we discussed Waymo, which is an industrial application. So we can use it both for the commercial purpose and also for